Greetings EGR 180 students, this is Unit 10, Assembly Creation and Modification. By the end of this unit, you should be able to identify the first fixed component in an assembly, create a bottom-up assembly with the following standard mates: coincident, concentric, perpendicular, parallel, tangent, distant, angle, and aligned, and anti-aligned options. Apply the mirror component tool, locate the center of mass relative to the assembly origin, create a coordinate system location, locate the center of mass relative to a created coordinate system. There are 4 questions on the CSWA in the assembly creation and modification category. There are 2 different assemblies. There are 4 total questions, 2 multiple choice, 2 single answer. Each question is 30 points each. That means the 4 combined are 120 points, or half of the CSW points. Because of this, the assembly section is where I always suggest you start the CSWA. To build an assembly in the CSWA, you'll first need to download the components from a zip file SOLIDWORKS provides. Remember to extract all before using the parts. Combine them to create the desired assembly. Then you'll modify each and fill in an answer. Typically, this is a measure function, such as what's the distance between 2 points, or what's the angle between 2 parts. I actually quite enjoy modeling assemblies. I hope you do too. They sort of remind me of Tinker Toys or Legos when I was a kid. Basically, just make it look like the picture. There are numerous tricks for working on assemblies, and I'll show you these in the Unit SOLIDWORKS 10 demo. I'd like to spend a little time talking about the 2 main modeling techniques we use, top-down and bottom-up. With top-down, the design intent comes from the top and moves down into the individual components. You make the first component with respect to the assembly reference planes. With the bottom-up method, the traditional method that combines individual components are developed independently. Then to modify component assembly using the bottom-up assembly approach, you must edit the individual part. With the bottom-up method, you begin by creating each component independent of any other component in the assembly. Then you insert the components into the assembly. The first component needs to be fixed or fully defined to the assembly origin. Then you mate the components in the assembly document as they relate to the physical constraints of the design. Remember that the first component or subassembly should be fixed to the origin or fully defined in the assembly document. You should see a little F next to the part. But what if this occurs? Something that occasionally happens with CSWA parts. The base component inserted into the assembly is not in the correct orientation for the final assembly. What would you do? Remember, the planar face you select for the base sketch of the part determines the orientation of the part in the document and the orientation of the part in the assembly document. The solution is to float the part and reorient it by creating a set of mates that orient the part correctly. The first mate is between the top plane of the assembly and the top face of the base 1 component. The second mate is between the front plane of the assembly and the top plane of the base 1 component. It is able to translate along the x-axis. The third mate is between the right plane of the assembly and the front plane of the base 1 component. The base 1 component is fully defined in the assembly document with 3 coincident mates. With the top-down method, 1 or more features of a part are defined by something in an assembly, such as a layout sketch, 3D sketch, or other geometry from another part. Edit components or insert a new part new in context to the assembly. The top-down method is typically used when redesigning or retrofitting a part when you're starting with an assembly that the part must fit into. With the top-down, you might design around the center of mass, or design in place and use reference planes, faces, axes. Think about the ability to design the pads for the brake caliper in the assembly shown. With the top-down method, external references are created to the geometry you referenced. An external reference is created when one document is dependent on another document for its solution. Assembly modeling requires time and practice. Here are some helpful tips and techniques. Create an assembly layout structure. The layout structure will organize the subassemblies and components and save time. Insert subassemblies and components as lightweight components. Lightweight components save on file size, rebuild size, and overall complexity. Use the Move with Triad or Zoom and Rotate commands to select the correct geometry in the mate process. Zoom in to select the correct face, edge, plane, or point. Improve the display by applying various colors and features and components. Mate with reference planes when addressing complex geometry. Example, an O-ring does not contain a flat surface or an edge. Utilize the View Mates option to view the mates in assembly associated with a component. This is hugely useful. View mates are typically the last item in the Feature Manager pane. Activate the temporary axes and the required planes from the menu bar toolbar. Select Reference Planes from the Flyout Feature Manager. Expand the components in the Feature Manager to view the planes and features. Remove display complexity. Hide components and features. Suppress components and features when not required. Utilize the Select Other tool. Sometimes this is the only way to select an edge or a face so that you can mate it or measure from it. Keep this in mind when measuring on the CSWA. There are times when you want to or need to suppress a component or assembly. There are three suppression states for assembly components. Resolved or unsuppressed is the normal state. A resolved component is fully loaded in memory, fully functional, and fully accessible. All its model data is available, so its entities can be selected, referenced, edited, and used in mates. A suppressed state removes the component temporarily from the assembly without deleting it. It is not loaded into memory, and it is no longer a functional member of the assembly. You cannot see a suppressed component or select any of its entities. A suppressed component is displayed in gray or ghosted in the Assembly Feature Manager. The third compression state is lightweight. With this, you can improve performance of large assemblies significantly by using lightweight components. Loading an assembly with lightweight components is faster than loading the same assembly with fully resolved components. Assemblies with lightweight components rebuild faster because less data is evaluated. Lightweight components are efficient because the full model data for the components is loaded only as it is needed. Only components that are affected by changes that you make in the current editing session become fully resolved. Here's how a typical CSWA assembly question is laid out. Build this assembly, locate the center of mass with respect to the illustrated coordinate system, download the zip file of components, unzip the components. Do not use feature recognition when you open the downloaded components, as you do not need the additional feature information. Here's an assembly example from a prior CSWA exam I've taken. This is one of the two drawings supplied. Note the notes. Typically, they would have you modify the 40-degree angle and recalculate the center of mass. All right, in this unit I covered how to identify the first fixed component in assembly, create a bottom-up assembly with the following standard mates: coincident, concentric, perpendicular, parallel, tangent, distance, angle, and aligned and anti-aligned options. Apply the mirror component tool, locate the center of mass relative to an assembly origin, create a coordinate system location, locate the center of mass relative to a created coordinate system. There is a Unit 10 SOLIDWORKS demo with an example or two of modeling assemblies. Special attention is given to mate tricks, and also using the measure tool. Hopefully by this time you're starting to feel confident about taking the CSWA. There is a practice test for this coming up to give you an idea of what it's like. Please email me with any questions or concerns, and as always, thanks for watching.